Good evening, everyone. Good evening. Am I audible? Good evening, everyone. Am I audible?
Audible, sir.
Am I visible?
Visible.
Yes, sir.
Yes, sir. Okay. Okay. It is 6:06. We can start now. First of all, I introduce myself. My name is Rajat Boni. I am from IIT ISM Dhanbad. I am a PMRF PhD scholar, and I am getting a chance in Nptel to take lectures on ground improvement, which is already taught by Professor Dilip Kumar Vaidya sir, and I will just discuss this in this live session only the summary of the week classes. Okay, and also for your kind information, I this video live session will be recorded and will share to everyone in YouTube channel, which by Nptel team, and also whatever I am discussing here, which material I am discussing here, everything will be shared by Google Drive to everyone. So don't worry about this. Uh, so in this session, I will first take the theory part of this week, discussing the summer. Hello. I will discussing the theory first, part first, and going to the assignment part. And after the end of the session, I will take the doubt classes about this live session. So now I share the my presentation about the ground improvement. So let's start. Is this PPT visible to everyone? Hello? Is this presentation visible? Is this presentation visible?
Visible, visible.
Okay. Let's start. We start with definition. First of all, what is ground improvement actually? Why we need it, and what is the further application of this ground improvement? First, the ground improvement is the procedure which is typically defined as the some technique to improve the poor ground condition. Ground improvement methods improve the engineering properties of the soil mass, which is treated to meet the performance as requirements. Why ground improvement is needed? Actually, in our day-to-day life, we construct huge construction is going on huge amount. So there is not available proper good ground conditions. So we need ground improvement technique. Here I am discussing why need the ground improvement. There is few points I am highlighted here that ground improvement is required for scarcity of suitable construction site, that is not available good site, good strength uh, of ground site, and there is many problematic soil which is causing the problem the construction site, foundations like that, and also the application, wide application of our uh, of our civil engineering projects, and also used for the cost effectiveness and economic purposes. With the increasing demand for urbanization, we need to venture more challenging sites and also build more commercial building, high-rise office buildings, and railway tunnels. And also for these, suitable sites with favorable ground condition are not abundantly available. And for engineering purpose, why we need ground improvement? Actually, we need ground improvement to increase the mechanical properties of the soil, because mechanical some soil have not adequate mechanical properties. Also, we deal with soiling and sinkage of the soil, and collapsible soils, soft soil, organic soil, peaty soils, sandy and gravelly deposit, karst deposit with sink formation, foundation on damp and sanitary landfills, handling dredge material, handling hazardous materials in contact with soil, and use of minefields. So every problem we facing, we can address by ground improvement techniques. We can come to that. Now I am discussing the materials which is already shared with you in NPTEL portal by Professor Dilip Kumar Sir, and I am summarizing this material uh, going through that PPT. First, we can start with introductory part of ground improvement. We can see that like every civil engineering material, soil also is one of the civil engineering material like steel or concrete. But in case of soil, it is very dynamic. It is it is not properly addressed sometimes. In steel or concrete case, we can manufacture it in laboratory or in field with quality control technique. But in case of soil, we addressing soil, it is very difficult because it is uh, in huge in quantity. So for that, we can use some improvement technique to improve our soil. Actually, soil form naturally and properties mostly not known depends on many factors and no control over its quality. Here we can see some here we can see some rock cycle, how soil is formed. In 4.5 billion years ago, actually our earth is in gaseous stage. After cooling, it is going to a molten magma. After further cooling, it is in igneous rock. Further weathering, it will become residual soil, and further heat and pressure, it becomes sedimentary and metamorphic rock. It means the soil formation of soil is depend on different mechanical and chemical properties. So it itself is dynamic in process. So for every soil, we can for different soil we can use different ground improvement techniques. Now, why it is needed? Already I told you that with the increasing the demand of urbanization, we need to venture more challenging site to build more houses. Commercial buildings, high-rise office building, highways, railways, tunnels, add them, etc. For that, not suitable ground favor is abundantly available. So here some types of we can discuss here some types of geomaterial or also can soil which is available or problematic soil, we can say problematic soil which is addressed by ground improvement technique. First we discuss natural soil. In naturally available soils are which is problematic in ground construction. It is soft clay, silt, organic soil, loose sand, expansive soil, and loose. What are the major potential problems? It is also uh, discussed here. In case of soft soil, it is very low in strength, high compressibility, large creep deformation, and low permeability. In silt, Same, it is low strength, high compressibility, high liquefaction potential, low permeability, low erodibility. Loose sand or organic soil, high compressibility, large cliff deformation. Loose sand, low strength, high compressibility, high liquefaction potential, high permeability, and high erodibility. Actually, this table is very important for your exam purpose and also to solve the assignment problems. Each and every point is very important to solve the assignment. Here we also there is a one soil is expansive soil which is very large volume changes occur. Loose soil which is available in uh, arid or arid region, it is in large going to large volume change and high collapsible potential. There is other problematic geometrical or soil that is field, and there is different type of field material that is uncontrolled field, dredge material, reclaimed field, recycled material, solid waste, bio-based byproduct. In uncontrolled field, the problems are low strength, high compressibility, non-uniformity, high collapsible potential. In dredge material, uh, there is the problems are high water content, low strength, high compressibility. In reclaimed field, there is also a high water content, low strength, and high compressibility. Recycled material, which is available in abundantly when it is dumped in a site when any construction going on, there is huge non-uniformity going on. So that is a one problem. Then high variability of properties also one of the problem in solid waste which is coming from our houses and also from factories, which is dumped on a site and construct building near it, which is also going to be problem. In that the problems are low strength, high compressibility, non-uniformity, and high degradation potential. The bio-based product also have low strength, high compressibility, and high degradation potential. Further moving ahead, there are some the table show that the geotechnical problem and causes. Here show the different problems and their overall causes and what theory based on this problem. First one is bearing capacity failure. Bearing capacity failure occur when the applied pressure is higher than the ultimate bearing capacity of soil. That means when the pressure is coming from the building is higher than the resisting soil pressure, then the failure of foundation is occur. Here some possible causes also discussed that when the pressure applied is very high. Also the inclined load, the load is inclined or the load is applied at a small area or the strength of soil is very low. Again, the other problems are large total and differential settlement. It is follow Hooke's law and also follow the particle rearrangement phenomena. Due to that, the volume changes occur and settlements take place. It is caused due to high applied pressure, loading area is a very large loading area, highly compressible soil, non-uniform soil, large cliff deformation. Ground heave takes place when soiling pressure is higher than the applied pressure. It occurs when the soil is high saturation or content groundwater table is above very high, and also soil is very expansive in nature and also frozen soil take place. When we say this instability, we come across the equilibrium equation. That means we equilibrium the forces. So instability takes place when the forces are not equal, and due to instability, the failure is take place. And it takes place when the shear stress which is coming from the structure is higher than the shear strength of the soil, or driving force is higher than the resisting force, or driving moment is higher than the resisting moment. It occurs at high earth structure, steep slope, high water pressure, soft foundation soil, high such as high loading rate. Moving forward, there are other few challenges that are liquefaction, erosion, seepage. In liquefaction, it happens when the effective stress becomes zero due to increased excess pore water pressure, and soil is treated like liquid, and soil is become liquid type. So foundation is not stable, and it is may failure the structure. It is occur when the earthquakes happen, and also there is below the foundation there is loose silt and sand present, and also the high groundwater table. Erosion takes place when shear stress induced by the water higher than the maximum allowable shear. Running it is occurs when running water is high speed or high water flow or highly erodible soil is present, like silt or sand. Seepage follow the Darcy's law. By Darcy's law, we can find the discharge and velocity, and we can also find the by Laplace equation we can find the Cp. It will occur when the high water head or high water table and soil also very permeable. Further moving ahead, there is some few techniques which is used in ground improvement techniques, which is used in uh, transport transportation infrastructure. These are aggregate columns. We use waste materials, electroosmosis, micropiles, biotreatment for subgrade blasting, densification, chemical grouting, like that, and many others, which we will going to discuss step by step in few next slides. Now, in module 2, sir will discuss different types of classification of ground improvement methods is given by different scientists in their different criteria. First is given by the Mitchell in 1981. It is based on the construction or function criteria. It is categorized in six. These are in situ deep compaction of questionless soil, pre-compression, injection and grouting, admixture, thermal, and reinforcement. Further, more scientists also classified the government students needs based on their own process, own criteria. That is, Hurstman 1990 based on process. It is categorized the ground improvement techniques in five. That is mechanical. That means by mechanical energy we can improve the ground. Hydraulic modification. That is by dewatering or drainage we can improve ground. By physical or chemical means or modification, by means we can physically replace the soil or and by problematic soil and replace it with good soil, or by grouting by chemical modification, that means the grouting or by chemical admixture we can improve the ground, or by some inclusion or confinement, that means we include rod or reinforcement in the ground and improve the increase the tensile strength of the soil. Actually soil is very poor in tension, so we can by address seeing we can address this by inclusion and confinement. Further moving ahead, there are et al and Chu et al. They are also given different ground information classification based on function and soil types, which you can go through and memorize it. So moving forward, Now we can classify ground improvement techniques by our own perception, that is shallow replacement, then shallow densification, then deep densification, then deep replacement, and like that. We can discuss everything step by step. First, shallow replacement. By name itself, it is clearly mentioned that we replace something in up to shallow depth. That is, here we discuss the ground, so improvement techniques, so we can replace soil. In shallow replacement, the methods are called over excavation and replacement method, which is widely used in up to shallow depth. It in shallow replacement, we remove the problematic geomaterial and replace with good quality geomaterial. Benefits are increase the strength, stiffness, and reduce deformation, and reduce the liquefaction, collapsible nature of the soil, and ground heave. It is suitable or it is applicable when the replacement depth is up to 3 meter deep, and it is also almost all types of geometry it is can be applied. But above 3 meter deep, this method is not suitable. Or also, this method is not suitable when the groundwater table is very close to the ground, or like from 5 meter, zero point 0.5 meter below the ground surface. Then this method is not suitable. Moving ahead, there is another ground improvement technique or classification, that is shallow densification. In shallow densification, there are three methods. One is traditional compaction, which is widely used, and another one is high energy impact roller, and last one is intelligent compaction, which is new and not readily available. In traditional compaction, we apply static or vibratory load on the ground surface in a certain number of passes. In each surface, it is improved. Each passes it improve zero point 0.3 meter thickness. Benefits are sorry, benefits are it increase the density and strength, stiffness, and reduce the permeability and collapsible nature of the soil. It's suitable, as I told before, it's suitable up to zero point 0.3 meter leap. That means in traditional method, in each passes we can improve only zero point 0.3 meter, and it is normally used only for finishing purpose in roads, mainly used in roads or leveling the ground. In last, if we can finish the leveling the ground, we can use traditional compaction widely. In high energy impact roller, we apply a lifting and falling motion of a roller with high energy impact. And due to high energy, the ground surface is densified or cast the problematic geometry. Benefits are same as little bit same as traditional compaction, but the improvement depth is higher than the traditional compaction method. In case of a traditional compaction method, we can improve up to zero point 0.3 meter. But in high energy impact roller, we can go up to 6 meter deep. And also it is suitable to improve the subgrade and foundation soil and compact the field. In intelligent compaction method, actually it is by name itself, it is show that we intelligently compact the ground improvement. That means we improve the ground whether it is mostly required, and it is very quick process, and it is not readily available. In intelligent compression, we apply and adjust the compression energy based on our broad display for measurements in real time. And benefits are increased density, strength, and stiffness, and reduce deformation permeability, collapsible potential, and maximize the productivity. It is suitable for granular material used to improve the subgrade and foundation soil and compact the field. like that previously told. And moving ahead, there is another classification is deep classification or deep densification or dynamic densification. In deep densification, there are uh, dynamic compaction, vibrocompaction, and also uh, sand compression column and stone column. So start with dynamic student. Each and every techniques which I am going to discuss here, it is elaborately discussed further module. So don't worry. Here I am discussing only gist of that techniques. So just in small way for understanding purpose. Each and every techniques we discuss elaborately in further classes. So don't worry. And now start with dynamic compaction. In dynamic compaction, we actually drop a heavy weight from a high distance, and due to heavy weight at a high distance, we the high energy can produce, which is improve the ground in a deeper depth. And due to high energy, it can cause causing the liquefaction of a saturated soil and problematic geomaterial and densify and settle down and densify the unsaturated polymetic soil. Benefits are increase the density, strength, stiffness, and reduce the deformation, liquefaction, collapsing potential, and to a greater depth. Benefits are like that more or same for every techniques. So I skip benefits next from next, and we can discuss now application for why it is and why it is suitable to apply. It is suitable for granular geomaterial, collapsible soil, and waste material with less than 15% fines and to a depth up to 10 meter and used to improve the foundation. In vibrocompaction method, which is also widely used, we apply a vibratory force or probe and water by probe on a surrounding problematic material and causing liquefaction and densify the soil. Benefits are same as previously told. It is suitable for clean sand with less than 15% silt or less than 2% clay to a typical depth of 5 to 15 meter. It is more than the depth is more than improvement depth is more than the dynamic compaction. That means it is more widely used than dynamic compaction, but it is used when the soil is soil having less than 15% silt or less than 2% clay. Moving forward in module 3, we can discuss further other diffusion techniques, that is sand compaction column and stone column. In sand compaction column, actually we displace the problematic geomaterial by driving a casing into the and backfill the ground and compact by vibration and any other means with sand. It is suitable actually. It is the benefits are little bit different previously told. Here increase the bearing capacity of soil and stabilize the soil and also reduce the settlement and liquefaction of the ground. It is suitable for a wide range of geomaterial to a typical depth of 5 to 15 meter used to improve the sand foundation. It is same depth as told for vibrocompaction, 5 to 15 meter improvement depth. In stone column, we actually construct the stone column by jet the air or water to remove or displace the problematic soil in the ground by a probe and backfill the hole with the stone or some heavy material to densify the column, to densify the soil by vibration. This also increase the bearing capacity and stability, and also reduce settlement and liquefactions, and accelerate the consolidation. Both compaction columns and stone column are used for consolidation techniques. Accelerate the consolidation because due to use of sand and stones, which is mostly permeable in nature, we can increase the drainage path of the soil, and water easily seeps out through these columns or drains columns. The stone column is suitable for a wide range of geometry to a typical depth of 5 to 10 meter, and use up to also can go to up to 30 meter and improve the foundation. Further move here, we can see the method how the stone column is constructed in the field. Here you can see that there are two types. Here only see for there is two techniques. One is wet top feed method or dry bottom feed method. Here it is only show the dry bottom feed method. In dry bottom feed method, step one, we penetrate the probe and then install the aggregate through the separate duct along the vibro probe, and vibrating the probe with high frequency 30 hertz, 60 hertz, and which is greater than the natural frequency of the soil, and soil easily displaced and compacted, and volume change and compacted. And also due to this sand column, we can consolidate or consolidation take place because the stones are previously told that the stones are permeable in nature, so water can easily pass through or seepage out this column. Now, like dynamic densification, there is another technique is deep replacement, which is little bit similar to deep densification. So there are two methods discussed here. One is rammed aggregate column, another one is geosynthetic encased column. In RAM aggregate collar, we pre-drill a backfill, pre-drill a hole and backfill with it aggregate and densify by ramming, or ramming nothing but is hammering. By hammering, we densify the column. It also increase the bearing capacity and stability and reduce settlement and liquefaction. It also accelerate the consolidation. This type of technique is suitable for a wide range of geometry to a typical depth up to 10 to 5 to 10 meter with deep groundwater table. When that means when the groundwater table is very deep, not close to that 5 to 10 meter, then this technique is very useful. In geosynthetic encased column, we drive a steel casing into the ground to displace the problematic geometry and replace the with a ground synthetic casing and fill it and compact it. So it also benefits same as the previous, that is uh, increase the bearing capacity and stability and reduce the settlement and accelerate the consolidation. It is suitable and economic for very soft soil. Only for soft soil it is very effective up to a depth of 5 to 10 meter. Moving ahead, there is another classification is drainage. By name itself, we can it is understand that we drain out the water which is problematic to our construction. Actually, water is very in construction. Water is very problematic because it can reduce the effective stress of the soil, which is base of the our strength, soil strength, and also reduce the shear strength of the soil. To reduce or drain out the water, there are two techniques are discussed here. One is field drains, which is widely used, Another one is drainage geosynthetics, which quite popular. In field drains, we place a layer of permeable fields inside the roadways or earth structure. When we place the permeable soil, the water can easily pass through them, and we can easily seepage out or seep out the water. Benefits are it reduce the water pressure and ground collapsible nature and ground heat, and accelerate the consolidation, which will further increase the strength, stiffness, and stability. It is suitable for low permeability ground geomaterial used for roads, retaining wall, and slope and length. The in drainage geosynthetic method, we place a layer of non-woven geotextile or geocomposite material in ground or inside the roadway or earth structure. The benefits are reduce the water pressure and collapsible nature of the soil, also reduce the ground heat potential, accelerate the consolidation, increase the strength and stiffness and instability and stability. It is suitable low permeability geometry and used for road retaining walls, slopes, and landfill. Further, moving ahead, there is another classification based on dewatering. It is similar type of drainage, but in dewatering we use extra force to pump out or to seep out the water. There are two techniques here is discussed. One is open pumping, another one is well system. In open pumping, we use pumps, trenches, to pump out the water in up to a shallow depth, a small amount of water up to a shallow depth in open excavation. And benefits are that pumping out water, it means that we lowering the groundwater table. By lowering the groundwater table, we increase the effective stress. Due to effective stress, we increase the bearing capacity of the soil. So it also increase the strength of the soil, and also it is benefited when by removing the water. It also benefit the construction technique. We can easily construct anything here. The pumping out technique is only suitable for small areas, relatively impervious soil, and lowering the ground table, but up to a limited depth. Because when we use open pumping, we apply small energy, so we and up only for up to a small depth. So we cannot go for deeper deeper dewatering. The next technique, which is oil system, by this we can go for very deep dewatering of the water. So in this, we use the oil point, different points and deep wells to remove the large amount of water in open excavation. The benefits are same as the open pumping, but in case oil system, we can remove water up to a greater depth. It is suitable for large area. In case of open pumping, it is suitable for only small area. But in oil system, it is suitable for large area and relatively permeable soil and lowering the groundwater table by a large depth. Further, the ground improvement technique is classified based on consolidation technique. Here consolidation is done to settle down the ground, which is very problematic. It is consolidation mainly done in soft soil or clay soil, because in clay soil it is very impermeable. So we go for an water content and water cannot seep out, so we go for consolidation. Here two techniques are used to consolidate the ground. One is field preloading and one is vacuum field loading. In field preloading, we apply a temporary surcharge or weight or heavy weight on the ground surface for a duration, then remove the structures for the construction. During that period, ground is settled down and construction is placed further. We can construction takes place. Its benefits are increase the soil strength and reduce the settlement. It is suitable for saturated inorganic clay and silt, and used to reduce the settlement for foundation soil. Like field preloading, which is widely used, vacuum preloading also used. In vacuum preloading, we apply the vacuum pressure to suck out the water from the ground and uh, apply ground the like preloading. We settle down the ground and remove the water from the ground. It benefits are increase the soil strength, reduce the settlement like that, and it is suitable for saturated inorganic clay and silt and used to reduce the settlement for foundation. Moving ahead, here we can see that there is a schematics diagram of preloading technique. Here we see that the ground is previously up to this much level. We see my arrow. Everyone, can you see my arrow?
Yes.
So that uh, okay. So you see that the ground is up to that much level. After applying the preloading, the ground is settled down. The ground is settled down and come to that level. And after settling down, we can fill the ground with good material, and traditional compaction technique is applied and leveling the ground, and further construction technique are going to construction, and it is suitable for construction. Moving ahead, we can see that another classification that is shallow chemical stabilization. By name itself, it is understand that by chemically we can stabilize the ground, and so the chemical stabilization is done by mixing the lime, cement, or fly ash with the subgrade and base course in the field, and then compact the mixture and uh, have the chemical reaction with the soil to form a cementitious matrix. Its benefits are it increase the strength and stiffness and reduce the ground heat potential. It also suitable for unsaturated clay and silt, and mainly used for roadway construction with a typical leaf thickness of 0.3 meter. That means it can improve the ground up to 0.3 meter. So by name itself, it is shallow. So it is the improvement zone is limited to up to 3 meter. Further moving ahead, there is deep chemical stabilization. In deep chemical stabilization, sorry for that. In deep chemical stabilization, we go for grouting, which is well-known technique, and another one is deep mixing. In grouting, we inject the grout into the ground to fill the voids and densify the soil, and have chemical reaction with the soil particle to form the hardened mass. Benefits are it increase the strength, reduce the permeability, liquefaction, and ground heat. Its applications are it is used or suitable for different ground geometries, mainly used for remedying the measures to protect the or protective projects. In deep mixing, we mix the cement or lime from a surface to deep with geomaterial. by mechanical bleed to have the chemical reaction with soil particle, uh, and after mixing they form the cementitious matrix. Benefits are increased strength, stiffness, and stability, and reduce the permeability, liquefaction, and ground heat potential. It is suitable for a wide range of geomaterial, mainly used for foundation support, earth retaining during excavation, and liquefaction mitigation. Moving here, we can see that it is already here told that uh, it is already told that it is mainly used these techniques for remedial purpose. That means all the structure is already exist, so we can improve the existing material only. So here we can see that the figure see that the by grouting we can improve that much of problematic part of the soil which is already existed in or construction which is already built here. And also deep mixing we can also uh, further improve the soil uh, which is all improve the construction which is already exist. So student, now we student we will take few break for 5 minutes and come in after 5 minutes and wait for 5 minutes while I join after 5 and take break. क्या बोले Welcome back, friend. Am I audible or visible? Am I audible?
Yes, sir.
Also visible? Am I visible or not?
Yes, yes, sir.
Okay, fine. Let's resume our lecture. So we discussing the different ground improvement classification or ground techniques based on different classification. Further, we can discuss in module 4 can discuss others ground improvement classifications based on field reinforcement. In field reinforcement, there are two techniques are used. One is geosynthetic reinforced slope. Another one is geosynthetic reinforced embankments. In geosynthetic reinforced slope, we use or we we can use or place a geosynthetic material in a slope at a different elevation during uh, during field placement to provide a tensile resistance, and its benefits are increased stability, and it is suitable for low plasticity field and mainly used for slow stability. In geosynthetic reinforced embankments, it is used if place the high strength geosynthetic at the base of embankment to provide the tensile resistance. Benefits are increasing the bearing capacity and stability. It is suitable for embankments over soft soil, mainly used for enhancing the embankment stability. Here we can see that first one is geosynthetic slope, reinforced slope, and second one is geosynthetic embankment. Here we can see, you see that there is a black dotted line in picture, right side picture. It is nothing but geosynthetic material. So first we laid down the geosynthetic material and fill the soil or another sands and compact it and wrap the geosynthetic material over it. One lift is created. Now, furthermore, same way, there is several procedures is going on, and we can build this type of embankment. It is beneficial because in geosynthetic material, it can take the tensile strength of the strength in from the uh, forces. So where actually soil is less in tension, weak in tension, so it can easily stabilize the ground by taking the tension from the applied load. Further, uh, other field reinforcements are mechanically stabilized earth wall and geosynthetic reinforced road. In mechanically stabilized earthwork, which is quite popular or widely used, it places geosynthetic or metallic reinforcement in the wall at different elevation during the during field placement to provide tensile resistance. It increases the stability and it's suitable for low plasticity free draining field. That means it is not suitable for clay and silt, which is quite plastic in nature. In geosynthetic reinforced road, we place a geosynthetic reinforcement on a subgrade or within the base course to provide the lateral constraint. Its benefits are increasing the bearing capacity and bearing capacity and reduce the deformation and base thickness requirement. It is suitable for granular base over soft subgrade. Here shows two pictures. One is geosynthetics mechanically used for roads. Another one is geosynthetics used for retaining wall. Another types of classification is in situ reinforcement. In situ reinforcement, we use two types of techniques. One is soil leaning, which is more quite popular, and another one is micropies. In soil nail, We insert a steel bar with grout throughout the whole nail in the existing ground to provide the tensile resistance and prevent the ground movement. It increases the stability and it's suitable for low plasticity, stiff to hard clay and densify the granular soil and raw, and mainly used for temporary and permanent slope and walls during excavation. In micropiles, we insert the steel reinforcement bar in a bored hole and grout in place to form a small diameter pipe, which is less than 0.3 meter, and provide a vertical and lateral capacities. Benefits are it increase the stability, protect the existing structure during ground movement. It is suitable for variety of geomaterial used for slopes, walls, and under pinning of existing foundation. Here you can see one example of or one picture of soil nailing. See here you can see that the dotted line are existing or original ground surface, and we can reduce that much and increase the width of the road or reduce the slope, or we can increase the stiffness, uh, we can steeper the slope by introducing the soiling mainly. It is nothing but insert the rod into the slope and grout them. And to protect them, one face covering is laid down. So by this we can increase the width of the road and reduce the uh, thickness of the slope. Moving ahead, there is another classification is thermal and biological treatment. In thermal, both techniques are not used widely. Occasion, it is only used when it is required to tackle the ground. In ground freezing technique, we remove the heat from the ground to reduce the soil temperature below freezing point and turn geomaterial into solid. Benefits are increase the strength, reduce the water flow and ground movement. It is actually suitable for temporary work or protection work during excavation, and also suitable for saturated clay and sand. In thermal and biological treatment, there is another one is biological treatment. It is actually used by utilizing the vegetation or roots. Actually, roots are control the erosion of the soil. So it can use the or increase the shear strength of the soil or change the soil property by biological means. Benefits are it increases the strength and stiffness of the soil and reduce the erodibility or erosion of the soil and reduce the liquefaction potential. It is suitable for cohesive and cohesionless geomaterial. It requires more research and field trial before it is adopted in practice. Now we now we go to the selection method. How can we select the method and when it is required and how it is utilized our, uh, for our construction. So if there is first we see that the building is constructed in normal soil. If the soil is good, oil enough to take the weight or load from the building, then no new go for ground improvement technique. Only simple shallow foundation can utilize or can solve the problem. If ground is then second is replacing the ground. It is this technique is going when the replacement of soil or problematic soil is in shallow depth. So we can replace the soil and good material can input it and increase the strength of the soil and building and resist the and soil can resist the building load. Further, if that is not covered, then further go for the compacted or consolidated ground technique. In compacted consolidated ground technique, we can compact the whole below, compact the soil which is below the foundation level, and we construct the building over it, and which further, if it is also not possible, further we can go for the composite ground technique. In composite ground technique, we can use for sand compaction column or stone column. If it is well good to take the building load, we then we stop here. If anything previously told technique is not good or suitable, then we go for deep foundation technique. It is not ground improvement technique. Actually, it is another type of foundation technique, like shallow foundation. In deep foundation technique, we actually construct the pile which is deeper enough to take the load and distribute the load uniformly, and it is uh, suitably uh, suitably take the building load without failure. Then another selection for slopes, which when we use for cut and fill, whether it is going to steep slope or flat slope. If there is places is limited or width of the place is so limited, we go for ground improvement technique. By ground improvement technique, we can reduce the thickness of the slope and increase the width of the road. Here you see that in first A, you see that the ground is normally normal condition, but that is there is no technique is used, that is unreinforced cut and fill slope. Here we can see that the slope is quite flat, and it is occupied most of the area or thickness of the ground. So we can reduce for our convenience by applying different ground techniques. One is earth walls, and another one is reinforced cut and slope, and another one is reinforced cut and fill earth walls. The first one is in unreinforced cut and fill earth walls. We actually, the thickness is very big, so we can better to go for reinforced cut and fill earth wall. Here we can see that the thickness of the wall is reduced by applying some inclusion of reinforcement, which will all good to take the tension of the soil. Now moving ahead, there is some factors which is depend ground improvement techniques it depends on. These are structural, these are geotechnical, sometimes it is environmental, sometimes is construction constant, and sometimes it is depends on reliability and durability. You can see here one chart which is based on one gradation chart. One is, which is in x-axis it is percentage final, and y-axis so x-axis it is particle size, and y-axis it is percentage final. This chart, by this chart we can easily, by this chart we can easily identify what technique is suitable for what type of soil. We see that there is range of quite range of soil particle size. So, for example, shallow foundation or shallow compaction, which is widely used, and almost all type of soil or all type of particle size can take place or suitable for this. For example, we can take particulate ground, uh, which is only for suitable for 0.07 mm, 0.057 mm to 75 mm particle size. like chemical grouts which is suitable for 0.475 mm to point 0.01. Like that, other techniques also describe here which particle size, which technique is going suitable and which is not. By seeing this chart, we can easily go through the. It is easy to understand which technique is used for what type of particles. Now moving ahead, we there is a flow chart which is neat what type of how to start our construction and how to select the ground improvement technique. Let's say we can start our construction. First, identify what type of construction it is. Either it is earth retaining wall or foundation support or roadways. After selection of what type of construction it is, we go for the geotechnical and structural condition by soil exploration techniques. That means we can explore the soil and identify what type of soil it is and how it is can behave, what phi, gamma, like that. After defining all the properties, we uh, go for uh, uh, we go for unimproved analysis. In unimproved analysis, we check the whether it is the ground is take the load which is coming from the structure. It is oil good or not. If it oil good, then no need to select any ground improvement technique. If it is not, then we go for different type of ground improvement technique. Here you can discuss here few like cut, shallow ground, like cut or fill or not, like shallow compaction or deep compaction not, or like unpaved or paved ground improvement technique. If it is yes, we can go for that. If it is no, we can change our technique. In last, we can also go for environmental and construction condition. And also we check our construction with reliability and durability. If all are correct, we can select correct or all are suitable, we can go for or select our technique. And after selection of our technique, we go for some field trials or validation or verification. After verification or field trials, we end and construction techniques are further construction are going on. It is the end of the fourth module. Now we come to fifth module. Here on fifth module onwards, we can discussing elaborately the different ground improvement technique which I discussed previously, like excavation. We start with here excavation and replacement technique. So we we previously discussed this excavation and replacement techniques is go for up to 3 meter depth, and it is only for shallow go for shallow depth, and it is also uh, suitable when the groundwater level is very deep. That means the groundwater level not close to that 3 meter depth. So if groundwater level is close to 3 meter depth, we dewatering the groundwater, or if the foundation depth is width of the foundation is B, we can excavate the field like zero point 0.5 to 1.5 B, like that, and also depth should be B to 3B, and B here is width of the foundation. Further moving ahead, here it is why it is used and what is the application of excavation and replacement method. In excavation replacement method, are used to improving the shallow problematic geometry like uncontrolled fill, loose sand and silt, and soft soil, expansive soil, liquefiable soil, frozen soil. Excessive deformation and potential bearing failure occur due to low strength during service, and it is used when area is over excavation is limited. Means the depth is or area of the construction is quite limited, and it is also suitable when the depth is less than 3 meter, and also it is suitable when the water table is quite deep or no or limit temporary shoring or dewatering are required. It is also frequently used when no existing structure is close to the our excavation area, and remove the soil can be easily done or disposed or reused. Or it also can be used frequently used when the field material is readily available. Here, uh, this method is beneficial to increase the bearing capacity, reduce the settlement, eliminate the expansion, sinkage or expansive soil, eliminate the freeze, throw or frozen soil. Actually, this method is commonly used to improve the geometrical under continuous or isolated footing. It is also used for highways or railways construction when problematic geometrical are encountered within the limited areas or and depth. Here some advantage and disadvantage discussed here. Advantages are it is often cost effective when the area of the depth are limited, fill material is readily available, and simple, reliable and well established, does not require specialty constructor or special equipment except excavator and roller. It is more more disadvantageous than advantages. That is, its method is unsuitable when the deep excavation is required. Method is unsuitable when high groundwater table is there. Method is unsuitable when the presence of on-site or nearby existing structure or utility lines. Unsuitable when the limited track access or site is inaccessible or inaccessible like that, or unsuitable when the distance is long or hauling fill material or disposing the excavated soil. That means it increase the cost of the construction for due to the long distance, and it is also unsuitable when the time is limited. That means quick construction, this method is not suitable. Further, here it is described the few uh, describe the principle of this technique. This technique actually used for partly or fully replacing the problematic soil by good soil, or sometimes the complete the replacement of the soil. Partial replacement is acceptable and more economical as long as the performance of the structure satisfactory on partially replaced zone. For expansive soil, which is may go for quite volume change, or for frozen soil, which will also go for volume change in nature and depend on temperature, it should be greater than the active depth of the problematic soil. For uncontrolled field, loose sand and silt, the depth of the excavation should be greater than or equal to the width of the foundation on the ground to meet the bearing capacity and settlement requirement. Moving ahead, there are we consider some design consideration. In design consideration, we need to check the depth of the displaced zone and also check the length and width of the displaced zone and fill quality including the strength and modulus of the fill. Here we discuss the failure modes. What type of failure is occur in this technique. These are the general shear failure within the replaced zone, then punching shear failure, within the replaced zone, then the distributed failure through a replaced zone, and the punching failure of a replaced zone into the underlying weak soil. To find out the bearing capacity of this problematic or replaced zone, we can use the normal general shear Tarjagi's general shear failure bearing capacity formula, which is nothing but Q ultimate is equal to CNC SCDC plus zero point 0.5 gamma dash B F N gamma S gamma D gamma plus gamma D dash NQ DQ, where C is cohesion of the soil, Q is ultimate bearing capacity, gamma dash is effective unit weight of soil, sigma D dash is effective overburden, NQ uh, N gamma and C is bearing capacity factor, SC SQ S gamma is shape factor, DC DQ D gamma is depth factor. Here is given the bearing capacity factor formula. You can go through it. Now we can also see that at different friction angle, that means the internal particle internal friction angle, soil to soil friction angle, we can define the different shape factors. That means SC gamma, SC SQ S gamma. Here for 0 degree, SC is equal to 1 plus zero point 0.4 into BF by LF, where BF is the width of the foundation, LF is the length of the foundation. And for 0 degree, SQ S gamma is 1. Like that, for other angles, from formula we can define. So we conclude the material. So now we can discuss the assignment problems. So we go with assignment. Is this these assignment are shared with you in the Google Drive. The solution also given here, and these assignments nothing but the NPTEL assignments. We can go through it, and actually I think the date is 8th August. Last date is 8th August. Before that you can submit it. The first question is here it is correct the statements about the soft clay from the options. So here it's given that the soft how the soft clay is problematic. It either it is loose. First option is given that low strength. Second one is high compressibility. Third one is low permeability, and D is not, all of the above. To answer this question, you can go through the material which is discussed previously, and also I can share here that in natural, you can see that slides which is already shared with you in Nptel website, that in natural soil there is soft soil column. In soft soil, it is given that it is low strength, high compressibility, and low permeability. So the first correct option is option D. That is all of the above. That means it has low strength, high compressibility, low permeability. Then we go next, moving to the next question. That is the correct the statements about the low strength geometrial from the below given geometrial. Here it is, we can see that option A is given that uncontrolled field, B is given that reclaimed field, and C is given the solid waste. But in question 2, it is uh, said that we find out the low strength geometry from this option. So we go through the same slides where it is that means in field we can easily see that it is given the uncontrolled field, reclaimed field, and solid waste. In uncontrolled field, we can see that uncontrolled field also has low strength, reclaimed field also has, or reclaimed field also has low strength, and solid waste also has low strength. The options, the correct option is option D. All of the above. The low strength is occur in all the field materials which is given here. Moving to the question 3, it is said that sand compaction columns are typically installed by which technique? First option is given that excavating the soil and replacing it with compacted sand. Second one is injecting sand slurry into the ground using the high pressure jets. Third one is vibrating a probe or casing to create a column of compacted sand. And fourth one is mixing sand and cementitious ground to form the solid column. So the here you can see that in last option in we can see that sand compression column is one of the type of ground improvement technique. It is classified on deep densification uh, technique. So you can go through the deep densification technique. You can see that the sand compression is a construction constructed by displace the problematic geometrical by driving a casing into the ground. That means casing is driven out or driven into the ground and then backfill this casing with soil or sand and compacted it. So the first last so option B, C, or D is not correct because it is in B it is said that it is injecting sand slurry and it is not correct. C is it is said that the vibrating approach. Sorry, my mistake. It is option A, B, or D is not correct. Correct answer is C. In A is not correct because here it is excavating the soil, but in sand compaction column it is not written that or it is not that we excavating the soil. Actually, we insert uh, casing into the ground and that casing is filled by the sand. So first option is not correct. Second one is B, injecting the sand slurry. It is also not correct. We not inject the slurry here. Fourth one is mixing sand and cementitious material, but it is included in the grouting technique, so it is also not correct. So correct answer is C, that is vibrating a probe or casing to create a column and then column is compacted by sand. So moving to fourth question, it is said that find out the instability of slope occur in the soil. But by below given option, we can find out what are the causes or which cause occur to the instability of the slope. The first option is given that driving force is higher than the resisting force. Second one is given that the shear stress is equal to the shear strength, and third one is given that the driving force is lesser than resisting force, and the fourth one is all of the above. This question answer is also given to this slide. We can find that in geotechnical problem and possible clause slide. Here given different types of problems. There is one problem is instability. In instability row, we can find that it is said that when shear stress is higher than the shear strength, or when the driving force is higher than the resisting force, or when the driving moment is higher than the resisting moment, then instability is occurring. So in first option, it is said that the driving force is higher than the resisting force, so it is correct. In second option, it is said that the shear stress is equal to the shear strength. It is not correct because the condition is shear strength is higher than the shear strength, but here it is given that shear stress is equal to the shear strength, so it is also not correct. After uh, option B is also not correct. Then C is tell that driving force is lesser than the resisting force, so it is also not correct. So correct answer is instability of slope when occur when the driving force is higher than the resisting force, that is option A. So moving to the question 5 in assignment problem, it is said that to find out the use of high impact roller. When we can use the high impact roller. The options given here are option A is increased deformation, option B is given that increased permeability, option C is given that increased strength and stiffness, and option D is given that all of the above. This question, to address this question, we go to the shallow densification technique. In select distribution technique, there is three types of techniques discussed here. One is traditional technique, another one is high energy compact impact technique, and last one is intelligent compaction technique. In high energy compaction technique, we go to the benefits column. We can see that it is benefited where benefits are increase the density, increase the strength, increase the stiffness, and reduce the deformation, reduce the permeability, reduce the collapsible potential. So from the option, we can see that here given that increase the deformation. So increase the deformation means here, but in benefits column it is given that reduce the deformation. So option A is not correct. In option B, it is given that increase the permeability, but here it is given that reduce the permeability. So option B also not correct. Option C is given that increase the strength and stiffness. Here it is also given that increase the strength and stiffness. So option C is correct. So correct answer is option C. Moving further, question 6, that it is tell that find out the process of dynamic compaction. That means what which involves in dynamic compaction. To address that, we go to the deep densification method or classification. And deep densification classification, we it, uh, so first discuss the options. First option is application of high frequency vibration. Second option is mechanically tamping using heavy machinery. Third option is control blasting of ground surface. Fourth option is insertion of cementitious grout into the soil. So you can see that in deep densification there is deep dynamic compaction. So in deep dynamic compaction is done when a heavy weight of hammer and high distance to apply high energy on the ground and causing the liquefaction of the saturated problematic geometry or densify the unsaturated problematic geometry. So in option A, it is said that application of high frequency vibration. It is not related to the dynamic compression. So option A is not correct. Option C is told that control blasting. It is also not related to the dynamic compression. So option C also not correct. Option D is told that insertion of cementitious grout. So it is also not related to the dynamic compression. So there is only option B. It is said that mechanically tamping using heavy machinery. Mechanically tamping means mechanically hammering. Using heavy machinery means high energy machines are used. So option B is quite related uh, to the dynamic compression which is discussed here. So correct answer is most probably option B. So moving further, we come to question 7. In question 7, it is said that excavation and replacement method is not suitable when the excavation and replacement method is not suitable. To address this question, we go to the module 5, lecture 5 of the module 1. Here it is discussed different suitability and advantage, disadvantage of this excavation replacement method. So here it is said that suitability said in disadvantage it is said that it is not suitable for the disc excavation and also not suitable for the high groundwater table. So in correct in this question, the correct answer is option B, both A and B. That is, it is also not suitable for deep excavation method and also not suitable for high groundwater table. So, correct option is option C. Moving to the question 8, it is said or find out that possible failure modes of foundation to examine during the excavation and replacement method. It is it wants the what are the possible causes of failure modes in the excavation and replacement method. The options given here are general failure within the replaced zone, punching failure of replaced zone into the underlying weak soil. Option C is distributed failure throughout a replaced zone, and option D is all of the above. To address this question, you also same go through the module 1, lecture 5. Here we can see the four type of failure modes are described. First one is general failure within the replaced zone. Second one is replaced failure within the replaced zone. Third one is the distributed failure through a replaced zone. Fourth one is punching failure of replaced zone into the underlying weak soil. So the correct answer is here D. That is option D. It all the above. That is, it comes general failure, punching failure, and distributed failure. So correct answer is option D. Now we come to the question number 9 of the assignment. It is that it is actually a real field problem is given here that it is said that a project site has a 5.5 mm thick loose gravel layer near the ground surface that needs to be improved for a foundation support. The method most suitable for improvement of the site. Here few methods are given here. One is option A is open pumping, option B is dynamic compaction, option C is traditional compaction method, or option D is none of the above. So from option A is open pumping, it is quite related to the dewatering the ground or dewatering the groundwater. That is lowering the groundwater. But our problem is not related to the groundwater table or groundwater saturation. So option A is not correct. Option C, it is little bit take, but it is little bit use, but up to a 0.3 meter. Here you can see that in shallow densification, the traditional method use up to 0.3 meter uh, depth, but that means it improve up to 0.3 meter only. But our we but in our problem we have to adjust or address 5.5 meter thick. So in traditional compaction method we can also we cannot replace or improve the 5.5 mm thickness ground. So the option B, that is dynamic compaction. If you go to the deep densification classification, we find that the dynamic compaction is go up to 10 meter. So it improves the soil up to 10 meter. So our problem only of 5.5 meter. So we can easily use this technique. So the correct answer go for this problem is dynamic compaction. So correct, which is address the 5.5 thick loose gravel and improve the foundation, improve the soil for foundation support. The last of the assignment problem is related to the general share bearing capacity formula of the general share value. Here it is told that the find out the shape factor value for the angle of intersection phi dash equal to 0 degree. Here few options are given. First option is when SQ S gamma, which is nothing but the shape factor of gamma and Q, is equal to 0. B option is gamma S gamma and SQ is equal to 1. C option is SQ S gamma is equal to 1.1, or D is none of the above. So to address the this question, you go to the last last uh, last lecture of this module. So we can find that general shear failure formula, which is nothing but Q ultimate is equal to CNC SC ADC plus zero point 0.5 S gamma B gamma BF N gamma S gamma D gamma plus sigma dash uh, NQ SQ DQ. Here we can find that the S gamma SQ and SC is equal to when phi is equal to 0, we can find that SC is equal to 1 plus zero point 0.2 into BF by LF, where BF is the width of the foundation and LF is the length of the foundation. And for phi is equal to 0, SC SQ is equal to 1. So the correct answer is here is option B. You can easily see that the SQ S gamma is equal to 1. So here I've completed the assignment problems of the NPTEL course, which will be shared to you in Google Drive. You can easily access from the NPTEL team. Also, a recording of this lecture will be shared by NPTEL team through NPTEL team. We can easily access later on. Now we conclude our session. So, anyone having any doubts, please tell. We discuss what type of problem we facing. We can discuss here. If anyone interested to discuss anything about this module, you can easily discuss. If anyone discuss anything, I am concluding the session. Is there anyone to discuss or to clear the doubt? I am waiting for few minutes. If anyone try to contact me, you can discuss with me. We can discuss. So at once I am concluding the whole session at once quickly. What I am discussing here in first module, first lecture. In first lecture one, sir discussed the different type of civil engineering material, and here also soil is one of the civil engineering material, and it is difficult to handle. So we can use different type of ground improvement technique, and also here discuss how the soil is formation from the rock, different wearing tear, weathering, heat and temperature, pressure, etc. By this, the soil is formed. Then we discuss why ground improvement technique is needed. Because here it is needed because not available, not suitable site is not available. Then we discuss here that different type of problematic soil, like soft soil in naturally available like soft clay, sealed, organic soil, loose sand, expensive soil, loose, and what are their problem. And then also discuss the different types of field, that is uncontrolled field, dredge material, reclaimed tree, recycled material, solid waste, bio-based product, etc. And also their problems, different types of problems. Then we discuss the different geotechnical problems and possible causes, which are nothing but bearing capacity failure, instability, sorry, bearing capacity failure, instability, ground heave, large total and differential settlement, etc. What are the possible causes and what theory based on it, and which all the discuss here. Then also we discuss the liquefaction, why liquefaction is happen, why erosion is occur, and why seepage is occur, and what theory background, what theory is based on it, and what are the possible causes here. Further, we discuss in lecture 2, we discuss the classification guarantee given by different scientists like that Mitchell based on the different criteria. Like Mitchell is given on construction of function, function is given this processes. Et al. Is given that in function criteria. So et al. Is given it on soil type and inclusion. Further, we classified ground improvement method based on our own comfort, like shallow replacement, shallow compaction, shallow compaction densification, deep densification, deep compaction, deep replacement, thermal compaction, thermal and temperature compaction, biofield, then grouting, chemical and shallow chemical stabilization, deep chemical stabilization, soil inclusion, then etc. Shallow replacement, we discuss the over excavation or replacement method, and we also discuss here how it is happened, what are the benefits and implications. In shallow densification, we discuss the traditional three types of techniques that are traditional compaction method, high energy impact roller method, intelligent compaction method, etc. Based on three techniques, traditional compaction method is widely used and most popular, and it is mainly used to level the ground or finishing over. Then we go to discuss the deep densification. In this densification, there are dynamic compaction and vibro compaction. Both the techniques are used widely used, and it is used different wide range of wide range of geomaterial, problematic soil, and also a quite deep depth, like 10 meter, 5 to 15 meter, like that. And also we can discuss the sand compaction column in module lecture 3 and stone column, which is widely used, mainly used for drainaging or consolidation, accelerate the consolidation and drainaging pumping out the soil or water from groundwater table, lowering the groundwater table. And it is also quite used high depth, 5 to 15 meter, sometimes up to 30 meters. Further, we discuss the RAM deep replacement method, which means we replace the soil in deep on greater depth. In here we discuss the RAM aggregate column, geosynthetic encased column, which actually these two methods are not usually used or quite popular, sometimes used. So it is not popular, but the improvement depth is 5 to 10 meter in both the cases. And also it is used to maximum used to accelerate the consolidation process. Then we discuss the drainage classification. Here we discuss the two methods, field drains and drainage with geosynthetics. In field drains, we actually use to accelerate and reduce the water pressure or accelerate the consolidation or same to increase the stability, increase the effective stress and bearing capacity, etc. Same thing we can also classify it by dewatering. In dewatering, we used open pumping well system. In open pumping, we actually pump out the water and lowering the groundwater table. In well system, same thing is happening but in larger depth. Both the method is suitable for dewatering or removing the water and quite is the construction site. But in open pumping, it is used only for small areas, and well system is used for large areas. Only difference is that. Then we discuss the consideration method. Everyone is well known about consideration. Here we use two techniques for consideration method. One is field preloading, another one is vacuum preloading. In field preloading, we apply the surcharge load and it is for a duration and uh, going for settlement and stable the ground and reduce the settlement. Same thing is happen in vacuum preloading. Instead of uh, surcharge load, we use vacuum pressure only. Our same benefits and application are discussed here, both the cases. Then we discuss the semi-chemical stabilization. In semi-chemical stabilization, we discuss the chemical stabilization of the subgrade and base. It is widely used and mostly popular in road construction, embankment, etc. It is up to zero point 0.3 meter thickness only, improve the soil. Then we discuss the deep chemical stabilization, which is nothing but the grouting technique and deep mixing. In grouting technique, we actually inject the grout in deeper depth by vertical probe or something, injector, etc. Same thing is happen in deep mixing also. In deep mixing, we use mechanical blade. Both the cases are for both cases benefits are same, application also same. Actually, both the cases are mostly used or commonly used for protective nature or protect the existing structure or already structure which is built to protect or remedy the structure or improve the soil. Then we discuss the field influence. In field reinforcement, we discuss the geosynthetics, reinforced slope, geosynthetic reinforced environment. Then we discuss the mechanical stabilize, earth wall, geosynthetics, reinforced wall, etc. At last, we elaborately discuss we discuss the how we start the ground movement technique, either it is required or not, what type of why how what type of tests are conducted, and when it is required, when not, what type of for why is going yes or no, and like that. Now then we discuss elaborately the excavation replacement method, when is required, how much depth it width also required, what is the effect of groundwater table on this extension method, what is the disadvantage, what is the limitation, what is the suitability, and what also discuss the principle, what principle based on it is, and also we discuss the design criteria, how much depth is required, how much length width is required, and what type of material is used, etc. And also discuss the failure mode, different type of failure mode, that is four type of failure mode we discuss, nothing but common failure mode it is general failure, then punching failure, then distributed failure, and then punching failure with of reflection into the underlying weak soil. Then here we show the bearing capacity formula and discuss the shape factors for different phi angle. So like that, we conclude here. Thank you. We will meet in next Saturday at the same time. So now we can close our meeting. It is already 8:01. So I am closing the meeting. Okay, thank you for everyone and wish you very happy weekend.